Hey guys, welcome back to the channel. In this video, I'll be covering how to graph functions and how to write general rules for functions for any case. So before we hop into the videos, show some support to the Swiss Army Tutor by subscribing to my channel and also smashing that like button for more content. So let's hop right into it. Okay, so if you guys remember in the last video, we said a function is a special type of relation, or a set of ordered pairs. Sorry about that, guys. Move that over a little bit. Pairs, not parts. Okay. So, what if we're given a relation? So let's just make a simple one. Just a set. I'm using set braces to signify. So I'm using these set braces. I'm bad at drawing them though, or writing them out. Just to signify that they're a set. 0, 0, 1, 1, 2, 2, 3, 3 in this set. Okay. All right. So to actually so now we want to ask ourselves, is it a function? Okay. So it appears to be, because there isn't any x's repeated for different output values, but we still need to check, and we can do that by just plotting the points. Hopefully you guys pay attention during your guys' pre-algebra classes when it comes to plotting points. So 0, 0, up 1, right 1, 1, 1. So that's 0, 0, 1, 1. That's 2, 2. That's 3. That's 3, 3. Okay. Let's add one more to set. Sorry about that, guys. I know I'm horrible. Okay, and it's -1, -1. So we'll go over 1, -1. Okay, so -1 and go down 1. It's -1. Okay, that should be enough points. All right, you guys see it's a straight line. If we connect points, go off forever in that direction, we see it's a function. All right, but see sets. So with a set, if we're given a set, pretty much we are going to we could do this and draw a picture, but we stop at the endpoint. Sorry about that, guys. We stop at that endpoint, and we can see if we take vertical lines, passing them through the x-axis, for every value of x, it passes through 1 point, and we call that the vertical line test. And I'll cover that in a separate video. But pretty much it passes the vertical line test, so it's a function. So if there was two values, say 0, 0, 0, and 0, 1 here, it would not be a function because it doesn't pass the vertical line test at 1 point. Okay, so we have that. All right, now what if we have a rule? So now what if we're given a rule? Sorry about that, guys. Let me flip my script over. All right, so what if we're given the same sets, but we're asked to find a rule? Or if we're trying to, we could just find a rule. So given the same sets, sorry about that, guys. So given the same sets, we were asked to find, just to give us a rule. Well, what we could do is we could make a t-shirt. X, Y. Okay, so pretty much what this does, and we just put all the points here. So -1, 0, 1, 2, 3. Okay. So we have, so let x be let x be the x-axis and let y equal f of x. All right, get used to f of x because that notation is used more common than y. And they mean the same thing. And then we have, for y values, -1, 0, 1, 2, and 3. All right, so to write a rule for the function, so the rule is f of x is equal to blank. So to write the rule for the function, we're looking for a pattern. So if we input 1, so 1 gets inputted, we get spit out -1. We put in 0, it spits out 0. We get 1, the function spits out 1. 2, 2, 3, 3. So what it seems like is for every input of x, we put in 1, we get the same output. So let's see if that's true. So f of x is equal to x. You guys are probably thinking. Okay, let's test that. So f of -1 is equal to, does it equal -1? Well, yes, it does. So, and we can test it with all the points, but that proves that this is the rule. Or it shows, it doesn't prove it, it just shows it's the rule. And remember, this is a straight line. We'll cover graphing linear functions by translations later. Translations and transformations. And other transformations. It looks like that. Okay, so try this one. So let's try another one. All right, so say we're given the sets. All right, so say we're given a t-chart. What is the rule? So we were given -1, so x, f of x, -1, 0, 1, 2. We were given 1, 0, 1, and 4. All right, so what this is saying is it spits out. So we put in -1 and it spits out 1. We put in 0, it spits out 0. Spits in 1. We put in 1, it spits out 1. And we put in 2, it spits out 4. If you go ahead and take a moment to pause this if you guys need to think about it. Okay, all right. So essentially, you guys are probably thinking, okay, we're multiplying by -1 because this gets -1. Okay, and then we get 0, so we're multiplying by something to give us 0, and we're multiplying 2 by something just to get its 4, to get to 4. And the only way 2 times 2 is 4 is by itself. Well, if you guys remember the definition of exponents, x squared, so any number, or let's do any number a to any power n is a times that many number of exponents. So if 2 times 2 is 4, -1 times -1 is 1. Well, that gives us that gives us a general pattern that we're squaring the numbers. We're raising it to a power of 2. So you guys are probably thinking, is f of x? So f of x has to equal x squared. All right, so let's see if it's true. If we input -1, we get 1. Input 0, we get 0. Input 1 into this, we get 1. Input 2, we get 2. Or 4, not 2. Sorry about that, guys. All right, so, and if you guys were to plot these points and connect the graph, you guys would see it's a parabola going straight through the origin. Kind of like that. It's more curved, but you guys get the point. And no pun was intended with that one. All right, so now just one last example. What if we were given a rule? All right, so say we're given a rule. All right, and you guys don't know how the graphs transform. You guys have been shown how to transform graphs from parent functions, which we'll cover in transformational graphs. We'll start off with linear functions and then move on to polynomials and so on. But, so say we're given this rule, y is equal to 3x plus 2. All right, and we want to graph it. Okay. So what we can do is we could plug in random numbers. So we can make a t-chart, x, f of x. and we get -1. And so let's just do -2, -1, 0, 1, and 2. So let's do 5 points. 5 points is more than enough to see how a graph transforms and behaves. So we could do -2, we plug it in. -2 times 3 is 3 times -2, plus 2 is -4. Circle that. -1 is 3 times -1 plus 2 is equal to -1. 3 times 0 plus 2 is equal to 2. 3 times 1 plus 2 is equal to 5. 3 times 2 plus 2 is equal to 8. Okay. So then we could just plot those points. So we have -2, 1, 2, -4, we have -1, -1, okay, we have 0, 2, we have 1, 5, 3, 4, 5, 6, 7, 8. So 1, 5, 2, 3, 4, 5. And 2, 8. All right, and you guys just connect the points. It's not perfect. It's better if you guys have graph paper, but pretty much it's a straight line. It should be a straight line. So pretty much just to recap. So if we're just given a set. So if we're given a set of numbers, or just pretty much a set, we could sorry, wrong page notes. Sorry about that. So if we're given a set, we could just plot the points and connect a line to graph it. We could also write rules based off of the points by finding a general pattern. Also, if we're just given a rule and we're asked to find the functions and you guys don't know the parent function, you guys could always plug in random points to see how the graph behaves. I'll see you guys next video.